why don't you try the same thing with x times y equals 6 and x times y equals negative 6. So go ahead and pause it and plot some points and make that happen. Okay, so I finished xy equals 6, and so we have, again, asymptotes at the x equals 0 and y equals 0 line. And then our line of symmetry is that y equals x line. Okay, so we could try the same thing with x times y equals negative 6. And once again, it's the same pattern as xy equals negative 8. Oh, that wasn't very good. Let me try to move that. Can't move that. Don't know how to. We have the asymptotes. At x equals 0 and y equals 0. And our line of symmetry is this y equals negative x line. Okay? So the centers of the above hyperbolas, like what are the centers? Well, the centers are going to be exactly between the two vertices, so the centers are the origin at 0, 0. Okay? So I want you to think of our whole, the pattern that we've been looking at with all of our conics, that the center is always, it's x minus the x coordinate of the center, y minus the y coordinate of the center. So couldn't we write the above equation as x minus 0 times y minus 0 equals 6, and x minus 0 and y minus 0 equals negative 6. So the center of the slant hyperbola with the equation x times y equals any number is going to be 0, 0. So let's take a look at the next example. So take a look at this one. Any guesses what the center might be there? X plus 2 times y plus 3 equals 6, or this one? Okay, what do you think might be the center? Well, I'm going to pick some points just to figure this out. Like, I just need to kind of back solve and say, well, some number plus 2 times another number plus 3 equals 6. A real obvious pair is 0, 0. So 0, 0 is going to be actually on that hyperbola. Well, now I might just go ahead and pick some random numbers for x. Like, what if I picked 1 for x? Well, that would make it x plus 2, or 3. This second quantity then would have to be 2, so it would have to be negative 1. So 1, negative 1 is another point that works. Well, what if I picked negative 1 for x? Well, then the first quantity would be negative 1 plus 2, or 1. So the second quantity would have to be equal to 6. So y would have to be 3. So negative 1, 3 is also on this. So why don't you go ahead and pause and try to think of some other points that actually work in this. One point that I come up with is 4, make that first quantity equal to 6, and then the second quantity would have to be equal to 1, so 4 and negative 2. So now I'm going to try to make both quantities negative. So what if I wanted the first quantity, x plus 2, if I wanted that to be negative 2, well then that would be negative 4. And if I wanted the second quantity, would then have to be negative 3, so this would have to be negative 6. So 4, negative 6 works, or negative 4, negative 6, excuse me. Well, what if I wanted the first quantity to be negative 3? Well, then I'd have to pick negative 5. And then the second quantity would have to be negative 2, so this would have to be negative 5. So negative 5 is also on this hyperbola. How about if you want to make the first quantity equal to negative 6? Well, in order to make the first quantity equal to negative 6, it would have to be negative 8. Well, if the first quantity was negative 6, the second quantity would have to be negative 1, so negative 8, negative 4 would work. And you're probably kind of guessing, you can probably kind of eye up that my hyperbola is going to look like this. So I'm looking for a point maybe down in this area down here, maybe somewhere in there. So I'm going to make the x-coordinate, if I make the first quantity equal to negative 1, well, I'd have to have a negative 3 in for x. And the second quantity would then have to become negative 6, and so this would have to be negative 9. So negative 3, negative 9 is another point. And again, we have our slant hyperbola. I'm going to draw in the asymptotes. The asymptotes are right here and here. And then the axis of symmetry is going to be right here. So the center of this one is going to be negative 2, negative 3. Again, notice the pattern. It's this is whatever subtracted from x, and this is whatever subtracted from y. So it still fits our pattern of conics. Let's do one last one, and what we want to do is we want to have x minus 2 times y plus 3. We want to think of numbers that would work to make negative 6. Again, the point 0, 0 would definitely work. Okay, not sure what just happened there. A little technical difficulties, but hopefully you heard me say that the coordinate 0, 0 definitely works there. So I am going to go ahead and plot 0, 0. Okay. Now, this is the first quantity, this is the second quantity. So what if I wanted to make the first quantity equal to negative 3 and the second quantity equal to positive 2? Well, this would be negative 1 and negative 1. And that would give me negative 3 for the first quantity times negative 2, or positive 2 for the second quantity. I'm sorry, that's a negative. So I'm going to plot negative 1, negative 1. All right, how about if we make the first quantity to be positive 3, so that would be 5, and the second quantity to be negative 2, so that would be negative 5. How about we make the first quantity positive 2, and then the second quantity would have to be negative 3. So y would have to be negative 6. So now I'm going to try to make the first quantity positive 1. I'm going to go for positive 1 times negative 6. So if the first quantity was positive 1, x would have to be 3. If the second quantity was negative 6, y would have to be negative 9. Let's make the first quantity to be positive 6, so x would have to be 8. And if the second quantity was negative 1, y would have to be negative 4. Okay, how about if we make the first quantity, let's make that negative 6. So x would have to be negative 4. And the second quantity would then have to be positive 1, so y would have to be negative 2. And the last point, I think we forgot one that's going to be somewhere in this general area here. So I am going through and I realize we forgot one. If the first quantity was 1, and then the second quantity was 3, that would give us negative 1 times 6. And that's our last point we're going to graph. So that's another slant asymptote. So the idea is I'm going to be asking you to just pick points and graph a slant hyperbola and be able to talk about where the asymptotes are. And you can oh, that was horrible, visualize that. And then where the line of symmetry is. Okay? And the center, again, is going to be right at that point. Again, right there. What's subtracted from x? 2. And what's subtracted from y? Negative 3. And that's the center. So to generalize, the center of a slant hyperbola with the equation x minus h times y minus k equals n, it's still going to follow that same pattern that we've been talking about. So hopefully you can get some extra credit on the test and be able to graph one of these, talk about where the asymptotes are, and talk about the center. All right, have a good weekend.